Good afternoon, everyone. My name's Andrew Bennett. I'm an advisor with the Kootenay and Boundary Farm Advisors, and I'd like to welcome you all today to a 1 hour webinar in the business of biochar and carbon credits. We're really excited today to have the Innovatree Carbon Group team with us. Lots of great stuff on the way. Before I introduce the Innovatree Carbon Group, I just wanted to mention a couple things about the Kootenay and Boundary Farm Advisors. Many of you are already aware of the services that we provide, but we help farmers in the region with technical issues. So we provide resources, we connect farms to expertise, we put on workshops and webinars, such as the one that you're on right now. And our idea is to really help farming thrive in the Southeast BC region. We are funded by 3 regional districts. That's Kootenay Boundary, Central Kootenay, and the East Kootenay, as well as the Columbia Basin Trust. And we're very excited to help farms at any time. So please do give us a call and let us know how we can help your farm. That's what we exist to do. And today, what we're hoping to do is connect you to a couple of experts who I've come across through visiting farms myself, as you'll find out in just a moment. We'll be starting off today with Dr. Sue Satyro. She's a chemist and environmental professional from Brazil, moved to Vancouver in 2017, a long background in environmental and chemical work, including years working at the chemical engineering department at UBC. And she has a strong focus on startups and entrepreneurship, and could be called a carbon strategist. Her expertise is really in biocarbon, carbon dioxide removal, and making money from voluntary carbon markets. The way that I got introduced to this in the first place was visiting East Kootenay rancher and entrepreneur Jeff Braisher at his very large multi-generation cattle ranch that sprawls over 40 kilometers and thousands of acres in the East Kootenay. A truly amazing ranch and lots of great ideas from Jeff. It was a really spectacular afternoon to see that farm and to hear about all of these startup companies he's worked on, boards, research and development, all at the interface between forestry, ranching, and environmental restoration. And at the end, we'll also have Dr. Garrett Whitworth on the line, another, you could call him an alchemist as well, a soil alchemist. So really a chemist. His expertise is in soils, carbon sequestration, and environmental analysis in agriculture and forestry. So a lot of those soil questions will be able to be directed to Garrett. Without further ado, thanks very much, everybody, for being here today. And thank you to the Innova Carbon Group for joining us. Please, Sue.
Thank you, Andrew, for the warm welcome. Thank you, everybody, to be here. As Andrew introduced us, our ICG mission is supporting First Nation communities and other clients to achieve long-term financial stability and success and contribute to health and well-being of the planet. So restoration projects are right on our alley. We are located in BC, specifically in Kamloops, and we are now a team of 7 highly skilled professionals. And Jeff is here with us today, and I believe Gareth is here as well. And we are going to start talking a little bit about biochar. So biochar, what is biochar? Like this miracle thing that can do 1,001 different activities, apparently. So biochar is a solid that is created from organic materials after heating at high temperatures without oxygen. Once you do that, it's a process called pyrolysis. So it's not combustion. We don't call combustion, but pyrolysis. And you permanently change the elemental composition of that what was once an organic feedstock into different products. And one of these products is biochar. Biochar is an ancient technology, as let's call it, as many of you known. We have known biochar because of excavations in the Amazonian area. And we found this areas where they shouldn't be as fertile, but they were fertile because of different practices that were made in these areas. And one of these practices was essentially smoldering organic materials mixed with different types of residues from the area, and they would then change the soil from that specific area, increasing fertility. We've known and get to know biochar in different areas in different areas of our period times, and until we got in 2000s, in the early 2000s, where scientific research really started to grasp what biochar is and what it can be done, and what are the results that can be achieved by using biochar, how the process of making biochar works. In 2010 was more like the breakthrough of it, where we accumulated as much as literature and work with evidence that biochar can actually be an important tool for environmental management. And this is where we are today. We are in the state of art of biochar, where we can choose different biochar inputs. And after we have like complex engineering systems, different engineering systems. Here there are 4 examples of different companies that produce pyrolysis systems to make biochar. Each one of these companies will have different specifics and different engineered designs to achieve biochar making. And this specific example, we have these values here, by the way, they're like minimum values. So you have a machine that's starting from 1,000 tons of input of feedstock that then is carried through a reactor that reaches temperatures above 600 degrees Celsius with no or very, very little oxygen. That said, after a specific time, biochar is produced and collected. Also, gases are produced, and those gases in different systems will be done different things. In this specific design, these gases are reinjected back in the system to keep the reactor at high temperatures, or also to dry feedstock as well. So the process regenerates itself. So you just need energy to initiate the process. After this is turned on, you'll never shut it down, like for 24/7 working. The excess of gas that you don't use for heating anymore or for drying material is transformed in thermal energy that is collected and is distributed for someone else to use, which can be as form as steam for a hospital, for example, or for heating homes and communities, these sort of thing. With that in mind, we can say that biochar making is like a great waste management tool, because we get from a waste stream, from organic material, we can transform into biochar that's gonna then build healthy soils. But building healthy soils is one of the things biochar can do, right? It can also be used in construction materials. We can produce then thermal energy that will be used in the facility itself, but also will be used in the community. And we can provide carbon removal services and then create also revenue for the project itself. So there are 3 different advantages. Which one of these advantages you bring a different revenue for that project, and you provide great environmental advantages by doing that. So We say biochar is restorative by design because by treating organic materials, we then regenerate soil, produce energy, and as a whole, we attack climate. It's a climate change mitigation strategy. That all said, what exactly is biochar, right? Biochar looks like all the same, like it's just like a black thing, right? Maybe different sizes, but like what exactly is? Biochar is actually a very complex material. It can look, once you look on without further investigation, it's all the same, but it's not. So mostly biochar is composed by carbon. Here there's an example that it goes like a carbon at 90%, but actually that can be from 50 to 90% of carbon. Then the biggest chunk is like on hydrogen and oxygen. Mixed with that biochar, you're gonna have ashes, so will be any other element that it's not carbon, hydrogen, and oxygen, and that will be still in the form of solid, will be mixed in that. The way all these elements, they combine will impact on how that biochar, what that biochar is and what that biochar can do. As you can imagine, if we make biochar from wood feedstock, probably will be that biochar will be different if we look at a biochar that was made out of grass, just because the original material is different. So this is one of the things that can impact the biochar properties. As an example here, you can see this table is from Pyrag, one of the biochar biochar reactors manufacturers, and they provide a general characterization of biochars made from different feedstocks and how they change. So for example, you can see that ash, the composition of ash in each one of these materials is very different. It can go from 2% of ash to 10% of ash. That all will be in your biochar after you pyrolyze it. So that will change how that biochar will behave. Also, the carbon content, you can go from 60% to 8 to 93% of carbon. So that later on also impacts on how much carbon credits how much carbon removal actually you can possibly achieve with that material. So biochar is not one material. That's very important it's a very important understanding to have about biochar. Many factors will come into play. So as I said, feedstock, depending on the feedstock, you're going to have a different biochar, but it also depends on the temperature. You're going to make that pyrolysis happen, how that temperature is distributed inside the reactor you're using for that biochar. So what you're looking for is to have same temperature in all over the pyrolyzer you're using. So you're going to have consistent and high quality material made. There is a time component on this. So how long your biochar, for how long that process is going to occur, and also treatments that you can do before making the biochar, after making the biochar. And that's all going to impact on the biochar properties, the application, how the carbon is stable into the biochar, because it's not only about the carbon content, but also how stable that carbon is. And then that stability will impact on the carbon sequestration capacity of the project that will use that biochar. Nowadays, the carbon credits that come from biochar are attached to biochar that can sequestrate carbon for more than 100 years. and we can analyze that in laboratory settings. So we need to be sure that the biochar we are making is up to those standards for carbon credits as well. Because we have like a large variety of how biochar is, what biochar is, which properties it have, that led the market to come, not the players in the market to come with certification process. So we can essentially be sure that those types of biochar are good enough for specific applications, or if they reach standards that would be good for specific applications. The most prominent certifications at the moment are from IBI. So this is International Biochar Initiative, and it's based in North America. It's based in the US. And we have also EBC, the European Biochar Certificate. Both of these standards, they are similar. However, EBC has more strict standards. And right now, EBC has certification for various uses of biochar. Each one of these uses going from feed from feed to basic uses in materials, passing through agricultural use for organic farms. Each one of these uses will have different standards to be achieved. And when I say standards, it's usually a long list of chemical analysis that you need to do. And each one of these chemical analyses will have to pass through limits that you have to be approved to be classified, to have one of these certifications stamps in your project or on a biochar you're making. So as for in biochar in soil, as mentioned before, it has been more than 20 years in scientific research demonstrated that the application of biochar in soil changing and significantly influencing like the chemical properties such as pH, electrical conductivity, cation exchange capacity, so organic carbon, availability of nutrients. So there is piling materials about it. Internally, we say in the biochar world that's quite hard nowadays to even do original research in biochar because so much has been done. What it has been doing now is just confirmation of what has been have been done in the past, and confirmation using biochar with even more specifics into it, so even more modification on that material. That's what is new in biochar. But in soil, we know already, science knows already what are the possible benefits of using it. And when I say possible is, again, it's going to depend on the biochar you're going to use in your soil, and it's going to depend of what your soil needs as well, and we need to match these two. That said, in farming or in agro and forestry sectors, we can match biochar use in different instances. One can use biochar in co-composting practices, in manure and slurry, then using later on that material into soil or into a greenhouse, then also in forestry, or you can also use it as in biogas production on site as well. There are great available resources, free available resources from different organizations, and I would like to highlight here the International Biochar Initiative. You can open their website. Andrew, can you see this website? Okay, so you can just go to their website and go to resources, and you're gonna have great resources for biochar. And they also have some tools to help anyone interested in setting up little trials to understand if that biochar work in their farms. So please feel free to visit that. There is also USB. Oh, sorry, clicked in the wrong place. Which is the US Biochar Initiative, and they have like a very nice education page where you can look for other people's work and understand a little bit more of what others are doing and how they got into that. For example, how to make biochar enhanced compost. There's a video, there's guides. It's great resources to have, and I strongly encourage anyone to visit those sites. If you're curious, there is also the Biochar Journal, who has a great list of 55 uses of biochar. And you can find examples of cascade use of biochar in animal farming, soil conditioner, building sector, decontamination, biogas production, and the list goes on. Great resource as well. So then we jump into as carbon dioxide removal. I understand that here everyone knows why we are doing this. I just wanted to highlight a few numbers that first we need to reach the 10 gigatons of carbon removal per year to keep below 2 degrees of warming. And right now we are below 1% of that 10 gigatons, which is not great. But we are working to reach that number up. And one interesting thing to notice is that from that less than 1%, biochar projects are 90% of 90% of that 1% is because of biochar projects. So biochar is the only real carbon removal technology that it can be applied and started at any time today. So from all the technologies that people are working on, biochar is the one that's the most close to be fully commercial. Of course, there is still a lot of hurdles to deal with. We are dealing with biochar. It's just in a scale. Like this is like the last hurdle for a technology to be fully commercial is to prove their scalability, how it can scale. But as far as carbon removal can go, biochar is the one that's the first one to be there, and it's the one that's delivering carbon removal right now. Biochar production until last year, we had more than 50,000 tons of biochar production capacity, and it's projected that we're probably going to double this value this year, which is great news. Again, we need to get up from those 10 gigatons a year. So doubling biochar production capacity is a great step to have. That all said, how exactly biochar removes carbon from atmosphere? Like a lot of people might think about it, right? So biochar is a combining strategy. So we're using like a natural solution and an engineered solution altogether. Who is removing carbon from atmosphere? It's actually plants. So we start from the traditional photosynthesis. Plants remove carbon, CO2 from the atmosphere. They grow, they're used and die. We get that. So they grow. Once they die, we get the material and then we pyrolyze it and transform in biochar. By doing that and then regrowing the previous area, where that feedstock came from, we keep the uptake from carbon from the atmosphere into plants and stabilizing into biochar. After we stabilize into biochar, biochar then needs to be deposited in a carbon sink, as we call it. And in this scenario here, we are specific saying that that biochar is going for soil applications. So by doing that cycle where plant grows, material, organic material is transformed into biochar. So then we stabilize the carbon into the biochar. We apply that biochar in soil, and we keep doing that cycle. That means we are then removing carbon. However, also by doing that, we are also producing energy. That's also a big part of this carbon removal scenario. Then, because we are removing carbon out of the atmosphere, we can create carbon credits. We can have this carbon removal service that can enable the creation of carbon credits on the voluntary carbon markets. After those credits are registered, companies that need to buy those carbon credits because they, right now, just because they want to, because that's the voluntary carbon markets, they buy those credits, that money goes back to the project and it keeps in financing that carbon removal sequestration, that carbon removal service. Right now, out of like carbon credits from biochar making facilities, and I'm saying biochar making facilities that are not in a research and development phase. I'm talking about facilities that are already on a commercial scale. Credits are from $115 to $250 US dollars per CO2 removed out of the atmosphere, in comparison to like forestry and carbon soil credits that are quite low, below $15 per CO2 removed. To do that, one needs to register the activities of those projects in in a protocol, or like you want a standard. For doing that, there are different standards nowadays that can be registering biochar technologies. These are the three most prominent ones. Each one of them have different applications. So depending on the activities of your projects, you're gonna be eligible for one, but you might not be eligible for others. Vera is the most strict one, and then we have followed by Pure Earth, and finally Carbon Future and CSI, which both of these ones are more have a bigger umbrella, which kind of projects they can register. Also, Vera requires a much longer investment of time and money, however, has like a longer, better returns for large projects. And finally, just to say that carbon removal projects are unique, even though biochar protocol is the same, the biochar technology is the same. What is important for a carbon project, it's not only about the biochar technology you're using, it's about where your organic material is coming from, where is it going, how much fuel you're spending in every step of the way, or how much carbon you're spending every step of the way until you have that biochar on into the soil. All these steps will be heavily scrutinized. There is a lot of documentation to be done, chemical analysis to be done, so many check boxes that needs to be checked to finally, once that biochar from that project is analyzed and will tell you how much carbon you're going to be able to potentially sequester by the activities of that project, that carbon will be from that carbon will be subtracted everything else you did that also expended carbon just because you made that project happen. So in the end, you will have how much carbon credits you're gonna be able to generate. And as an example, and I know I'm out of time, once, from an example of potential revenue, when I say potential revenue, is because considering all the carbon that's in the biochar, if all that carbon is converted in potential carbon removal, one can recover from carbon credits up to 220,000 US dollars. However, you still have to discount all the carbon expenses you had by putting that project up and running that project. Oh, thank you. Open to questions after, and yeah, great to be here.
Thank you so much, Sue. That was really a fantastic introduction to what's obviously a very vast subject. About the double counting of carbon credits. So, for example, if you get carbon credits for selling biochar, but then the biochar is applied to an agricultural soil, and farmers are also maybe in a system of trying to get carbon credits from increasing soil carbon. What's the process that eliminates the potential for double counting credits?
So right now, as far as I know, a project that is registered by using biochar cannot be registered from other carbon projects. So for soil carbon, for example, you do one or the other nowadays. So you can't register the same area to be used for both types of sequestration.
Okay, that's great. And we'll have more time to go into any of these questions later. The other one I just thought might be interesting right now is selling carbon credits feasible on a small scale?
Is selling carbon credits is feasible in a small scale? It depends on first, it's going to depend what is the small scale we are talking about. I want to say if you're making the small scale, in my mind, goes as one of those systems I demonstrated before, and it would be a minimum of 1,000 tons of a year of organic feedstock. I would say that is feasible but there is much more to that. There is much more to developing that project to be able to be feasible.
In terms of cost effective, like at a certain.
Yeah, because in terms to be cost effective, because for a biochar project to work, you will need your carbon credits, you will need your energy uptaker, and you're gonna need to sell that biochar. So you have three products, and you're gonna be able to sell those three products.
Well, that's great, Sue. Thank you so much. We'll have more time at the end of Jeff's, and Jeff's is going to probably answer some of these other questions I'm seeing. So looking forward to what you've got for us here, Jeff.
Yeah, thank you, Andrew. Thanks, Sue. I appreciate that. So we're a couple things I wanted to touch off, I guess, right off the bat is scale. Scale, as Sue said, depends on what you're talking about, sort of thing, but scale seems to matter. Scale is, I don't think, let's put it this way, at this point, it's probably not reasonable to create biochar in your backyard and then sell carbon credits off that basis. So what I wanted to do now, though, is kind of bring this down to our specific project that is occurring locally here, and so and just, I guess, tell a story about how we got here, and then some of the agricultural impacts that have occurred and that we've learned. And I mean, to be honest about this whole situation, we've been on a steep learning curve for a lot of years now, and we've made our fair share of mistakes. And so as we've gone forward, we've been able to sort of figure out how we're going to pull these things together. But when it comes back to the carbon component, that's really one component of this whole picture that we're talking about, and sort of the benefits to the soil, the benefits to agriculture, and what we can recognize across the spectrum of sort of what's what works and what doesn't, sort of thing. So to get to get to this point, as I mentioned, this was a long journey. We started this sort of this journey probably. Well, I remember fairly well when we had a conversation with a local generator, where I'd sort of discussed with them about some of the challenges they were seeing on the environmental side. And originally we weren't thinking biochar when we started down this specific project. That definitely came later as we moved through. But in 2014, we sort of had this initial conversation, and what we were looking for at that point in time was, okay, well, let's look at, rather than landfilling everything, can we do something else that's beneficial for the soil, beneficial for beneficial for the farm, and then is also works for the generator in terms of not landfilling material. Right off the bat, we knew that there was going to be some significant challenges, and we spent the last number of years overcoming those challenges. And so I remember talking with scientists back in 2014 after we sort of had the approval. Okay, well, let's take a look at what we can do here. And I throw out some pretty out there ideas, but biochar in the context of what we're doing here locally starts off at a very high pH. And so the problem with that, of course, is that as you apply high pH onto already high pH soil, then you're going to run into challenges with your nutrients in your soil. Now, the other thing is we just didn't know much about this material back then, and so we had to learn about it. So I had talked with a few scientists, and I remember saying to one of them, I'm like, well, if we apply this and it increases our pH, can't we just dribble some acid onto the soil and lower the pH that way? And I mean, with the benefit of hindsight, that was a nutty thing. But the thing is it was sort of kicked off discussion. It's like, okay, well, what are we going to do? So I had this idea about, what we could potentially do with getting this down. But, my background is finance and agriculture. So, I really didn't have the skills to do so myself. So 2015, Garrett was working with Thompson Rivers University and had his own consulting company. And I was introduced to him at that point in time, and it was a good fit. He was willing to listen to some of the nutty ideas that I had at the time, and then actually apply some real science to it so that it could guide this process. So 2015 is when we started with lab scale, and it was a pretty humble beginning in that regard, where we just took samples of material, and then in the lab we tried to see if we could amend it in a way that was scalable, and it turned out at the end of the day that we could. Now, again, I don't want to overlook this thing with pH, because the pH and to a lesser degree the sodium levels in the biochar, irrespective of where it's coming from, those factors need to be taken into account. These types of things are overseen by the regulatory authorities in the province too, but a lot of those regulations are for pretty good reasons. So monkeying with your soil pH, for instance, not a good idea. So by the time we got to about 2017, we started to figure out, okay, well, we need to take this out of the lab, and we need to get this big enough that we can actually scale this up and be able to do this on an industrial scale. So doing so took a bit of time. We made a lot of mistakes in sort of just the mechanics of it. Now, biochar isn't, I guess the big thing about this is one biochar is not the same as another. Back in these days when we were doing these kinds of experiments and looking at how do we bring the pH down, we didn't really know what we were dealing with. We just didn't know what this material was. We knew it was high carbon, but above and beyond that, so what? It wasn't until we started to do some testing at later days that we went, there's some pretty interesting properties with this material, and what is it actually, how does it actually sort of perform when it's in real world environment. So So we started applying it to soil at first in a controlled fashion, and then we started to say, okay, again, how do we scale up? So in this particular slide here, this was kind of a hilarious thing, because we had to do basically what we call an acid reduction test, and what we wanted to know out of this was kind of what was going to take to lower the pH, at a little bigger scale. So on that particular day, there was a lot of hunters going by, and when they were looking at us in these hazmat suits and kind of peering into this mixer, a few of them are kind of like, yeah, what's going on here, sort of thing. So it was kind of funny to see their reactions. But this test was really important for us to understand the buffering capacity of the what is now biochar, or what of that biochar component. So so basically what we did is we mixed up a batch of this stuff, and then we started and then we took it and applied it onto the ground in one of the fields, and we did that in the fall. And then by the time the spring arrived, then we could start to begin to see the effect. So here in the bottom right corner, I guess I assume everybody can see my cursor, hopefully, but this was sort of like not too long after the ground had bared off. And this was where we had put up, that small mixed batch of material. And, and then you can see kind of like from UAV footage at the time, you could see where it was applied, and, we did several different amounts and tried to just get a little bit of a taste of what it could do. And we looked at this very small scale. Back at this point in time, we didn't even have a way to properly spread the biochar. We were just using essentially what was a prill spreader, and and it was like dumping a slurry that resembled concrete into it. And it was very interesting to see how equipment performed in tasks it wasn't intended for. So. But at the end of the day, though, right out of year one, we did see some interesting benefits to the grass, and so as you start to scale up, it takes quite a bit. And so scale matters. Scale absolutely matters in the context of this, because it's difficult to perform all the activities. It's difficult to perform the treatment. We had to invest quite a bit into this program just to keep it, to progress us ahead. So, when we start doing this, again, to get to the point of carbon credits, that wasn't even what we were thinking of back in these days. We were just thinking, how do we logistically pull off this thing in a way that's actually going to be of a benefit? So, as you can see, there's a lot of iron involved and a lot of other challenges. So where we are today, so after those sort of activities, when it gets to the farm, now we're talking about the actual amendment. And so as of 2023, we've expanded the area to encompass around 400 acres of land. We're utilizing, up to 10,000 cubic yards a year of biochar, and the thing is though, is that sort of varies depending on what the generator output is, and interestingly enough, I think Sue kind of touched this. Basically, when it comes to what's occurring on the feedstock side, it all translates into what the outputs are. And that can be in terms of volume, or it can be the metals compositions, or a whole myriad of factors that come into this. And so as we move forward, then we start to figure this out, sort of thing. So biochar does have, separate from the carbon credit conversation, biochar definitely has some very interesting benefits to it. We've got some very good yield data. We're looking at some indications where biochar can effectively help to remove, or not remove, but let's say not allow nitrates to leach out into the water quite as readily. I wouldn't go as far to say that it stops it by any means, but it seems to slow it down at least, because it's a stable product. The thing is that we're not just talking about a benefit in year one and you're done. And our data seems to indicate that too, that those benefits are, sort of last for quite a period of time. What that looks like when it stops, it's probably difficult for us to tell at this point in time. But from what we have done, you're seeing sort of a ramp up in production, and then as time goes, I would expect to see like all else being equal, sort of like the beneficial effects of it to slowly wane. As Sue pointed out, though, the terra preta in the Amazon, it shows some pretty amazing things, but keep in mind though that there are obviously some very big differences between soil in the Amazon and here. So on the Rocky Mountains on the side of the hill, right? So this particular photo here kind of made me laugh a little bit, and I guess just a bit of a side story here. I took this photo because Garrett spent so much time out in the field poking holes in the field looking for samples, that at one point we were kind of joking amongst ourselves that it was like we weren't sure that the effects were from the biochar or if it was from Garrett just aerating the soil one sample at a time. So but anyway, I don't want to overestimate the amount of testing that went into this. We looked at, we looked at what was going on in the soil. We looked at what's going on in the forage. We looked at sort of like, what the heavy metal component is, and not just for compliance with the land application plan, but also, just in the context of understanding what's going on. And so, when you factor all these things in, then you start to get a picture of what's happening on the ground, because what we're putting onto the soil absolutely affects what's happening both in the plants and both specifically with the livestock. And, soil pH is the big one we think about, but even the nutritional content and those changes that occur within the plants are something that you've got to account for. You can't sort of overlook that because it can create situations where perhaps that feed's a lot richer than you might expect, and of course that has health implications with the livestock. So I guess one other thing I just wanted to say is biochar is a good source of potassium, phosphorus, calcium, and micronutrients. The interesting thing about micronutrients is that they're often overlooked in the context of a nutrient package for I don't know if overlooked is, but they're a little more difficult to nail down in the context of a nutrient package for what's occurring on the land base. But they can actually have pretty outstanding impact. So with that said, though, the micronutrient component is not something that we looked at too much in depth outside of sort of more anecdote, where, for instance, the boron that was coming in from the biochar, basically we weren't necessitated to add boron in with our fertilizer that was coming on as well. There are some more elevated sort of nutrients or micronutrients that come in, such as zinc. It needs to be, we sort of got to keep in mind what's coming in with the zinc, with the biochar, which again, it means a lot of testing. And within the context of Innovatree, we have some pretty great expertise in there to make sure that that what is occurring is safe and within compliance and is going to be beneficial. So now, as far as handling the biochar, incorporation, as you might expect, is always going to be best. And I mean, the obvious one is, of course, that once it's incorporated in the soil, the big thing is that it's readily available to the plants. When it's not incorporated into the soil, it can still be a benefit, but there's a couple of things that you really got to keep a really close eye on, and that comes back to specifically dust, and I'll talk to that specific point a little bit later. But you know, in terms of learning, and from a logistics perspective, that dust component was something that we didn't see coming, quite frankly, and yet had some, you know, had the potential to be some pretty significant impacts, both on you know, like field activities and but also if we, you know, we're pretty isolated here, so we don't have a lot of neighbors, but you know, in terms of you know, that dust, you know, creating a problem for other people, you know, that definitely can be a component. So again, I guess on this particular slide, all I really wanted to demonstrate here is that this side, you know, you can kind of see the visual difference here. This side was incorporated preceding, and this side was not. We surface applied it and allowed it to sit there, and then, you know, the plants grow up. And you can kind of see, if you look closely and carefully, you can see kind of the differences in visual yield. Now you can measure that, and we did measure that in a number of other examples, not this particular one on say crop height and that type of thing. But what we found is that surface applying became available usually in year 2, and then again in year 3, and so the biochar, when it was surface applied, if it was done correctly, then it would slowly work its way down into the soil, and that was a result of, you know, perhaps, you know, microbial activity and weathering, and, you know, a combination of factors. But you know, you could when Garrett was pulling samples out, you could see the profile, you know, as the biochar slowly worked its way down through. So that was a little bit unexpected, because when you see biochar sitting on the soil surface as it is, you kind of, you know, it doesn't look like it's going to go anywhere. It's fairly granular. It's not, doesn't look like it's the type of product that you know, would just move through the soil readily. But it seems to, you know, the worms and the biology in the soil seems to enjoy that. So the other benefit, I guess, is that this biochar provides a scaffolding for sort of bacterial growth within, or you know, microbes within that soil. That sort of is, I guess, Sue put it this way, it was kind of like little condos for your soil microbiome, which I thought was a really interesting way to put it. So again, surface applying can work. It's kind of cost effective to do it that way. Couple things, like for instance, with surface applying, I guess we had to be careful when we put the cows on. It was easy for secondary ingestion, that type of thing. The other thing is just the compacting action of the cow hooves would break the structures of the biochar and then allow it to be in a position where it could be airborne. So it's like, we just learned that we had to do a couple of specific things. So I think I've got a slide coming up here that'll show some of the challenges with dust. So I guess we can talk about it later. So obviously, I guess from the science perspective here, sorry,
Jeff,
go ahead, Andrew.
just for a sec, just wanted to time check. We've got about 4 minutes left in the hour. If you're willing to keep going, that's great. I just wanted to didn't know where everybody's time's at here.
All right, I'm okay on my time, but if I'll try and speed it up here. So okay, pH is an important factor. We talked about that. It just can't be overlooked. There are situations where, you know, if you're starting on low pH land already, it could be used without having to do the process that we do. In our area, it's not possible. We absolutely must amend the pH before we begin to do that. So the ash residuals, or biochar in this case, so they start off very high. We need to be down at 8 or below before we begin application. So okay, now this was interesting to me, and I guess this is why I wanted to show this particular slide, is that What I didn't know prior to this project is I always assumed pH was fairly static. And, you know, I didn't think it moved around much, but as you can see from this chart here, it kind of bounced around depending on the time of year, moisture conditions, you know, what other factors were going on. So it was, you know, it was kind of interesting to see, you know, that it just wasn't dead flat. So not exactly what we're expecting. This is back to where we did some of the initial trials. We did obviously these here. Garrett set up a randomized control trial, and then we had another set of trials that were existing on here to initially kick us off. Now, this was where some of the initial data came from on what was going on. It was how we managed to parse through and see what was truly the effect of the biochar versus what was, you know, just natural variations or whatever the case was. I guess in terms of application rates, you know, we had 3 different application rates, and at the higher end of the application rate, what we're targeting is within the guidelines of the provincial regulator. We wanted to see if we can increase that potassium level up to a level where you know, this kind of becomes a self-fulfilling thing. So here's, I guess, just to jump through this pretty quickly. Here's a number of the things that we're looking at, along with the standards on the right-hand side, and then of course, you know, what we were doing with the after effects of the application of the biochar. So again, we're doing a lot of testing on the heavy metals. We want to keep a really close eye on that. We want to make sure that those metals are not increasing materially in the soil. And you know, after a number of years, we did finally figure out, well, I shouldn't say finally figure out, but you could see as time went on that, you know, that the levels, the sort of metal levels in the soil weren't being moved materially, sort of thing. And so, you know, that's important for sustainability. You know, the thing is that we weren't too interested in doing this for a period of time and then being like, well, we can't do this anymore because the metals content in the soil is too high, and that's got all sorts of other problems. So early on days, we were looking at some of the UAV imagery. So we did using multi-spec analysis, we tried to establish what was occurring in the soil from a plant health perspective. I would say that with the benefit of hindsight, we probably only recognized modest benefits from that. It wasn't something that I think we found that could have been scaled up, but it was kind of like we stacked research projects at that point in time. So very quickly, the big thing I wanted to show here is just the yield data, crop. So not yield data, but crop height in inches. So generally speaking, the higher the application rate, you know, we could measure the benefit of that biochar, and then of course, you know, we measured the actual volume being harvested both in a small control scale as well as at scale sort of thing. So you know, I mean, it was very clear within time that the biochar was producing a positive result. We'll say though that biochar again is absence of nitrogen, and so you know, just because we're putting on biochar, it does not mean that we couldn't or that we could get away without applying any other nutrients. So this became very important because this is another one of the factors that we had to look at very, very closely in terms of, you know, what the soil is going to need, you know, what's going to happen with the soil in time. And actually, because we saw an increase in yield from the application of biochar, what you also saw is an increase in the uptake of the nutrients that were already existing in the soil. And so, you know, you could see at times that the soil nutrient levels were actually decreasing, you know, due to that, you know, we're harvesting those nutrients all the time. So within the crop context, This becomes really important when we're talking about livestock health. It's important to know what's occurring in the crop and how that's going to translate into what the livestock are going to need for a mineral package. So we had to work with a number of other professionals as well, even in the context of this project, to balance out those nutrient levels. So I guess when it's all said and done, one of the things that we want to sort of reiterate in this is, again, because of scale, the amount of testing that you need to do, the amount of sort of adjustments that you can do, it allows for that, quite frankly, where if it's too small scale, one thing that would be a challenge, I'm not saying it can't be done, but one thing that could be a challenge is that, it is possible to introduce unintended side effects that can be difficult to account for, and can translate in things you would really not like to happen. So challenges. Dust is, from a logistical perspective, dust is a major challenge, and the biochar is very interesting because dust is relevant to human health, it's relevant to livestock, but it's also really hard on equipment. And that was something that we never saw coming, quite frankly. The seals in hydraulics, for instance, anything that was moving, it wore out at a rate that was exponential to what we normally would have expected. So logistics, again, scale, you want scale, but handling larger quantities can be a challenge. So, and again, a lot of the rest of this is just things we've talked about already. Secondary ingestion of biochar by livestock. We don't really know if that was a major problem per se, but it's something that we had to, I guess, pay attention to because it affected what was happening with the nutrient, the mineral component within the livestock themselves. So, even if the grass tested at, or the forage tested at a certain constituent, secondary ingestion could throw that off anyway. So it's just one more little detail that we had to think about this at scale. So monitoring, we monitored an awful lot, and again, a lot of it was for satisfying the regulator, and ensuring, but a lot of it was also just to ensure that we could account for these little challenges that kept cropping up. So just really quick, I guess we don't need to spend a lot of time on this, but when biochar gets crushed, it's very, very airborne. It's very, very light. At a zero moisture content, it tends to be about 230 pounds per cubic yard if there's absolutely no water, so oven dry sort of thing. And of course, that creates lots of dust. So from a challenge, so this bottom picture here, I guess, is really just like as we were flying up to sort of observe, you can see it looked okay. And then as we went over the field, you can see the remnants of the biochar. And then of course, on this photo here, it's like, you can kind of see the dust cloud following the equipment around. So, we've got charcoal filters in those, but we're able to get away from that simply by altering how we apply, and just some of the things that some of the things you don't do post application, time of year, what the conditions are at time of application, so on and so forth. So and conclusions. So we've got just to quickly reiterate, the ultimately, I guess what it matters for in the context of livestock is quality and yield. Quality of the forages was good, and the yield, we did see a fairly substantial yield increase after a period of time. So again, it took a little while for that biochar to be available to the plants, and for there's a bit of a process that occurs even after it's applied, where the biochar almost needs to be colonized. And then, it'll almost like suck up the nitrogen for a period of time and then slowly release it on the back end. So the carbon sequestration, I guess that's really the thing with SUT. That's something that's fairly new for us. So what I had told you was a story of how we get to this point, and it's like it wasn't a straight line. And what we're looking at today is not at all what we thought we were going to be looking at. Around 2020, 2021, Garrett started to do some tests that would show, started to show what the carbon was. And what was interesting to me is that above and beyond the actual carbon that we were putting out on the soil, we were seeing a lot more carbon that was actually sequestered and was measurably sequestered in the soil than we expected. The obvious question is, well, maybe we just put on more biochar than we thought, but it's more complicated than that. And to be honest with you about that whole perspective, we don't really understand precisely what's going on from that perspective. But what we do know is that from a sequestration perspective, this is a good story. We're able to meaningfully contribute to carbon sequestration with some fairly modest changes to the actual soil, at least from like a high level perspective. Is it going to save the world? Probably not. But there's some very compelling reasons why biochar is good for the soil, good for the farm, good for the environment, and can lead to some good conclusions. And I think from the generator perspective, I see this as a win-win situation. So and when it's all said and done, quality biochar equals quality forage, which equals happy cows, and that's what we're really shooting for in all of this. So thank you.
So there's a number of questions here. Some of them have been answered in the chat, but I thought I'd bring them up since not everybody has seen the chat. Right off the top, Ryan asked about the cost of trucking the material. He said he'd looked into biochar in 2013 and as a soil amendment or for carbon sequestration, but the cost of trucking was a real problem. How's that math balance out now?
It's a real problem, but the cost of logistics is a challenge with this, and that's as much of a consideration as anything in these types of projects. So you sort of got to separate it out as to sort of like two things. One is, okay, if you're going to make biochar on your own and you're not going to worry about carbon credits or anything else, then what you've got to sort of look at is like, okay, what's the secondary benefits of the biochar, and those can be substantial. If you're looking at industrial scale, logistics is the single biggest challenge that can make or break a project. So scale, you have to work on scale. You have to be able to justify that somehow. If it's directly related to just one component of it, then odds are, as you probably found out, it's not likely to be economical to complete. So we had to look at it. Okay, you can generate carbon credits, you can generate you can create a kind of a waste diversion sort of thing, and so when you piece all these pieces together, that's really the main thing that makes these projects work. And so in our case, things came together well for this particular project. But with that said, I mean, we've got we're not the only ones doing this, and this is being scaled up across the province. So I think the thing is that there's a number of ways that these projects can be put together. So, but it's a good observation with the logistical component. I guess one thing that I didn't mention, even above trucking, is the amending process that introduced another pretty complicated challenge that we had to overcome. And it's not necessarily specific to anywhere else, but specific to here. So there's, you couldn't economically truck this too far. Let's say that. So.
Thanks, Jeff. A couple of questions on smaller scale. So, one of them is there was a question about low cost or low tech processes. So, I know a lot of what we're talking about is larger scale equipment and processes that are quite well controlled to develop a biochar that is consistent and certifiable and can go through all of the paperwork. Uh, I guess the question would be the costs and benefits of uh, doing something a little bit more fly by night in your backyard. Is there a risk to making your own biochar and throwing it in your soil, or even trying to sell it, or can that work out for people? It's a bit of a tough question, I know.
Yeah, I'll preface this with what I can say. We never really looked at the small scale right from the start. But a couple of challenges right off the bat that I can think of is just understanding what the biochar is that you're making. You would need to keep a close eye on the pH. If you're making it, you would need to keep a close eye on sodium. Depending on what you're using for an input sort of feedstock, that can affect what the constituents of the biochar are from a safety perspective quite substantially. So, for people that are really keen to learn and are willing to put in the effort to do it, yeah, absolutely. But I think Garrett might have something to add to this one though. So he's looked at that more in depth than I have. So,
Hi, Garrett.
Hey, yeah, nice to be here. Quickly, if it's small scale and you're able to kind of find something off the internet to produce biochar in like an economic manner, as long as you're using like a clean feedstock, I don't know, ground up wood chips or some kind of dried feedstock that's not going to have any kind of contamination, you should be relatively fine when you're keeping it to like, I don't know, 1% of your 1 to 5% of your kind of content in your plants. We've even done stuff in research greenhouses with marigolds at up to like 50% biochar composition, and they actually work out really well. From a food perspective, though, you're probably not going to get too much other than some nutrients and some low volume metals that the tree is sucked out of the soil itself. So just going back to the soil. But yeah, don't burn anything painted.
Nothing toxic in the feedstock in the wood, and keep the quantities reasonable in the soil, and you're probably okay. A related question is about mobile burning units. People are obviously thinking about something that could travel around, so that maybe you could have a business making biochar on site, visiting various people's stashes of wood, turning it into biochar and going to the next. What's the feasibility of a business plan that would look like that? Garrett, you started answering a short answer on the chat, but maybe you could expand on it a bit.
Yeah, I mean, I think it's pretty low. At this point in time, I mean, like an air curtain burner or something like that, going out into the bush and burning up slash piles or something. One, you've got to be able to kind of get that out of the bush again, so truck it out. And two, it depends where you live, but fire is always a risk when you bring something like that into the bush. But then the units are quite expensive, and from a lot of Sue's work, you really have to be able to capture everything that's produced, and so in that case, you're not generating anything from the thermal energy, and you're probably having some relatively expensive setup and tear down costs. So the market from the market for biochar is just not lucrative enough by itself to really justify that at this point in time.
Okay, thanks. I should mention that Sue's been knocking some really great links into the chat there. I've copied them down, and we'll make all those links available to people. But there are people looking at this. There are companies working on it. This might be a question for you, Sue. A number of questions about the uses besides adding to your soil, perhaps in some kind of manure management or even as a feed for cattle. Did you have any thoughts you could share on alternative uses in agriculture for biochar other than as a soil additive?
Yeah, so like biochar, like the biggest use is soil, but that cascades as like you can co-compost with other feedstocks you have on site, or but you can also, there are studies much more in Europe right now using as cattle feed, as someone raised in the chat as like a potential methane reduction, emission reduction, but that's still up to debate. So people has been using more as a health strategy for cattle in feed. Um, and you can use it in manure and then later on use that in your co-compost pile. So all kind of like funnel to a compost strategy that later on you're going to be using in soil in an agricultural setting.
Yeah, one other thing that we did notice here that biochar does contribute is actually odor reduction.
Oh yeah.
That was an interesting one because sometimes maybe there's more information than you want to know, but once in a while, if you have a cow that dies in the winter or something like that, you've got to do something with that animal. We have predator problems in this area, so our main goal is to make sure that we're not feeding them and teaching them to feast on livestock. So everything that dies, we've got to bury. And in the middle of the winter, that's even with the equipment we've got, sometimes that can be challenging, let's say. So one thing that we've done is temporarily, until we can bury them when things thaw, is we'll take an animal that has perished and we'll put them in a biochar in like a little sort of cover them, that sort of thing. And it doesn't actually take that much. And in doing so, you can basically eliminate the odors completely. And how we know that is because we had cases where we had wildlife walking through, and they walked right by the pile and never touched the livestock that were under there. It wouldn't have been a big deal for them to unbury them, but I was quite surprised that it was that effective. And then, of course, as soon as you can get a machine running or whatever the case is, then then we'll unbury it and bury the animal and whatever, and then apply the biochar, when it needs to be applied, sort of thing. So odor reduction, it was more effective than I would have expected. Let's put it that way.
That's a fantastic point, Jeff. I mean, that's a really major issue for many farms. I know we get tons of questions about keeping wildlife out of composts as well. So that's helpful. Also, what you mentioned earlier about the buffering capacity to stop or to at least reduce or mitigate nutrient flows into more sensitive areas and wetlands and this kind of thing. So lots of uses. A final question, and then let everybody go. Just about the condo effect, as you called it, Sue, with the way that biochar is able to encourage life to grow in these various situations. What is there any research into the benefits of this? Because I know there's a lot of talk about it, but it's a very difficult thing to measure since there's so many variables and so many life forms. What is the state of research right now on the condo effect?
That's a great question. People are still grappling with like how to measure specifically the condo effect, right? Definitely what I can say, I did hands-on work in growing bacteria on biochar, and definitely we could measure the bacterial growth incredibly higher when biochar was in, and that was in water. So bacterial growth in wastewater from mining sites, while using biochar or not using biochar, or using things that there was no condos for growing, like as controls, the life growth was not as big. But I'm sure that one can, if look into it, can potentially find it. There is a lot of advancement in laboratory studies on bacteria, so you can definitely follow which kind of bacteria is growing and quantify that through like various methods. So I would say that one can look for those most recently for studies, more recently studies, and definitely will find something like that.
And Garrett, is there any chance that that condo effect has an impact on people's yields?
Yeah, for sure. I think one of the things to point out is the high porosity and cation exchange of the biochar. So you're going to have more availability of the nutrients for the plants, as well as to the microbes in the soil. And that high porosity just gives them more growing space in your soil. It's like a extended lattice in the soil for more bacteria to grow. And then that the cation exchange and the better availability of nutrients, even though you have the same kind of amounts of nutrients, is going to increase the crop growth.
Thanks so much, Garrett. And thanks so much to the Innovatree Carbon Group for coming out today and sharing so much of your expertise and experience with us. Jeff Braisher, Sue Satyro, and Garrett Whitworth. Very, very pleased to have you all with us today. Thanks so much. And feel free to contact the Kootenay and Boundary Farm Advisors with any farm-related questions, but anything to do with biochar, absolutely give us an email, give us a call. And if you're trying to work on a biochar business, maybe we'll be able to set you up for an hour or two to hear from these experts on how you may or may not be able to make money monetizing carbon sequestration or your biochar. Thanks very much, everybody.